our final speaker of the day. The other finalists in our methods track the open track portion of the reproducible research competition. We have, as I make sure I get the slides open. We have Lee Kennedy-Shaffer. All right. He is an assistant professor at the Yale School of Public Health. So I pull this up. All right. His primary research interests are infectious disease, vaccine study design. He has the unfortunate consequence of his life being a lifelong Mets fan. I'm so sorry. But we're excited to have him present his research here today as a finalist in the competition. So I'll turn it over to Lee. Take it away, and let's give a round of applause.
All right, thank you very much. So in my day job, I use what are known as panel data causal inference methods to study vaccines and health policies and programs. And today I'm going to use them for something a little less depressing and perhaps almost as controversial, though, which is rule changes in Major League Baseball. So as I'm sure you all know, there have been several big rule changes over the past few years to try to speed up gameplay, get a little more action on the bases. There was a really good poster out there by Ryan earlier today, so hopefully some of you saw that, looking at a bunch of these. I'm going to focus in on the shift ban. So this is, again, to try to get more base runners. They decided to limit where the infielders could stand on the field. So the traditional infield setup is more or less what we see on the left here. And then a lot of left-handed batters were being shifted towards what we kind of see on the right, and it's a little fuzzier where everyone's standing. And MLB said, no, we want it to look more like the left. You have to have two infielders on each side of second base. And this came in starting with the 2023 season. And so we're going to look at this after the fact and say, is it working? Is it working for the league's goals? Is it working? How is it affecting individual players? And we're going to do this by looking at panel data, which is data where we have time series, multiple units, in this case players or types of players, multiple time periods, in this case seasons, and units that are affected differently by this rule. So some people we expect to be affected by the rule change a lot. Some people we don't expect to be affected by it. And this is one approach that we can do after the fact. Prior to this rule being implemented, a lot of people did modeling approaches, right? We can track these balls. We learned about ball tracking and fielder probabilities this morning. You can say, okay, in that environment, if the same hits had been made as in 2022, which ones of them would have been caught? That's really useful in predicting the effect. This is for after the fact evaluation, because at the same time as this rule change is coming in, there are other changes that might affect the offensive environment, and pitchers, batters, fielders, managers are all going to react to this rule change. They're not going to act the same way they would have in 2022 under the old rules. So we're going to use two different methods here that fall under this causal inference framework. One is known as difference in differences, and the key assumption there is that our group that's affected and our group that's unaffected would have parallel trends in their outcome over time if this rule change never happened. And the other approach is going to be the synthetic control. These are both approaches that we see a lot in economics and political science, as well as health policies. And the synthetic control, the idea is for any affected player, we want to find the group of players that kind of best match what they look like. So we'll start with difference in differences, looking at from the league's perspective, these big picture impacts. So we can track over time prior to the rule change, the outcome of interest. In this case, we're looking at OBP, on base percentage, for left-handed batters and right-handed batters. This is in situations where the bases are empty. So this is a situation where a lot of left-handed batters are shifted and most right-handed batters are not shifted. And you can see kind of prior to 2022, right-handed batters tended to have a lower OBP, but they kind of move in the same direction. When one goes up, the other one goes up. And so that's that kind of parallel trends that we'd like to see. The astute mathematicians will notice it's not quite parallel, but we'll get to that, or we'll not worry about it too much at the moment. And then we can track it into 2023, into this new rule environment. And what we see is right-handed batters went up by a little bit. That's that blue dotted line. Left-handed batters went up by a ton. So that indicates changing this rule, right? Taking away this defensive option that was potentially hurting left-handed batters meant that left-handed batters were doing much better. And if we take the difference between these two groups in 2023 compared to their difference in 2022, that's our estimate of the effect of this policy. And that's what's happening in the bottom graph there. So all of the green dots are for prior seasons when there was no rule change. You would expect those to be kind of scattered around 0. And then 2023, we see this big positive effect. And it's around 10 points of on-base percentage. And so it says, because of this rule change, left-handed batters improved relative to right-handed batters by about 10 points of OBP. It comes out to actually a similar number, kind of coincidentally, for BABIP. You can look at other outcomes depending on what you're interested in. But again, the league is looking to put people on base, so this is what they might be trying to highlight here, is 10 points. And then in 2024, now there's no rule change, and so they go back to being pretty parallel to each other. That 10 points kind of persists into 2024. So that's the big picture, right? The league wants to know that. They're going to pitch that to all their advertising and broadcast partners, say, we got all these lefties now are getting onto first base, so it's much more exciting, so give us more money. The players also would like more money, as would their agents, and their teams would like to do better. So we might want to know, okay, which players is this actually affecting and how much is it affecting them? It's going to have a differential impact on different players as well. So here's where I'm going to use the synthetic control method. Again, if you look at some of Mike Petriello's writing, as this rule was being discussed and then implemented, he kind of points out a few players that he thinks will be impacted by it, especially based on that modeling analysis. One of them is Corey Seager, Jose Ramirez. All of these he points out as people who are likely to benefit from this rule change. So the idea, again, of the synthetic control is we have some players who are shifted very frequently. Those are the players we want to know about. And then we need some other players who aren't going to be affected by this rule. So we're going to look at players who are shifted less than 15% of the time and say they're not going to be affected that much by this rule change. We're going to put a limit, a lower limit on the number of plate appearances just so we get things stabilizing a little bit. And then for each of those targeted high shift players, we're going to find a weighted average of low shift players that best matches their outcome from before the rule was implemented. So what's the group of players kind of that's the most comparable for the outcome? And then we're going to apply those same weights to what actually happened to those low shift players in 2023 to get our estimate for what would the high shifted player have done in 2023 if this rule hadn't changed. And the difference between that and what they actually did is the effect of the rule change on them. So I'm going to focus on Corey Seager. The Shiny app, if you're interested, has a bunch of other players you can play around with, different outcomes as well. So Corey Seager, we model him. The blue line is how he actually did each season. The orange dotted line is this synthetic control, this weighted group of other players, how they did. And so you see it's designed by the model to fit pretty well before the policy is implemented. And then when they diverge, that's saying there's some effect of the policy. And it's saying Corey Seager is doing better after the policy change compared to this group that he was similar to prior to the policy change. And one of the nice things about the synthetic control is it forces you to have a relatively small list of comparable players, and they all get weights between 0 and 1. So we can write out, well, this model assumes that Corey Seager is about half Trey Turner and a quarter Gene Segura, and a little bit of Carlos Correa and Jose Abreu sprinkled in there. And that means you can compare it to other measures like similarity scores, or you can just think about whether it makes sense to you. So if you need a conversation starter at the networking session tonight, you can argue about whether this is a good synthetic Corey Seager or not. And we see Corey Seager gets a really big effect estimate here, about 100 points of OBP. So he's actually one of the people that this model identifies as having the biggest impact of this rule change. You can look at a bunch of other players. All of the other target players are in purple. You can see their estimates are generally positive in 2023. And we compare it to people who, if we applied this model, we would expect to see around 0. That's what the green group is. Happy to talk more about the details of that afterwards if folks are interested. So for causal inference, you got to believe in the assumptions, just like you got to believe in the Mets year after year. We need parallel trends or stable weights for our synthetic control. In other words, those people we're comparing Corey Seager to, we need there to not be any other big changes that happen to any of them. We need no anticipation that people didn't change their behavior before the rule came into effect. We need no spillover. We need to assume that the rule didn't actually affect those low shift players very much. And we need the other rule changes not to have differential effects as well. So there are a lot of assumptions that go into it. But what we get out of it is a real estimate of what actually happened due to the rule change, if you believe those assumptions. And you can even track it over time to some extent and see, are teams changing their behavior and reducing that effect of the rule change as we go farther along into later seasons. So I hope some of you maybe think it's a useful method. If you haven't seen it before, I encourage you to try it out in some application you're interested in. You can see the code on my GitHub or play around with the Shiny app if you're interested in looking at other players on there. So thank you very much.
All right, big thank you to Lee.